Hello, everyone. My name is Lisa, and I'm glad to see you all at Winter Data Meetup organized by DataZen Community and Community Day. Meet Sai Varshith, an expert in MLOps and ML Engineering, ready to share how to build AI systems at scale. Learn the key steps, common challenges, and best practices for making AI work in real world businesses. Don't miss this session on designing smarter, more efficient AI solutions. Before we jump into our session, I would love to take a moment to ask for your support in growing our community and recognizing our incredible speakers. If you are enjoying today's discussions and want to stay updated on upcoming events and talks, please take a second to hit the like and subscribe buttons below. Your participation not only acknowledges our efforts, but also helps us reach a wider audience, allowing more people to learn from these insightful discussions. Also, in the video description, you will find a link to the talk page where you can share your feedback, award the speaker a badge, and raise a session. Your input is incredibly valuable. It helps us improve future events and ensures our speakers get the recognition they deserve for their hard work. Additionally, we would love to hear from you throughout the talk. If you have any questions or insights, feel free to drop them into the chat. Our team will be actively monitoring and we will gather your questions for the Q&A session at the end. Your contributions make the discussions even richer, so don't hesitate to participate. And now, let's welcome our speaker to share his valuable insights with us. Sai, floor is yours.
Yeah, sure. Thanks, Lisa. Thanks for introducing me to the audience. Hi, everyone. Hope your week is going good. I'm really glad that you're here with me today. So I'm excited to be part of this talk, and I wanted to talk something crucial for AI and ML teams around navigating some common pitfalls as part of their SDLC process, and also about how do you create scalable AI solutions efficiently. So today we'll divide our talk into three primary categories. The first one starts with understanding the problems and challenges a lot of AML teams face, and then we'll explore the current solutions that are in market. And then finally, I'll present a structured approach on how do we overcome the challenges that we usually face while building AI solutions at scale. So let's dive in and get started. So my name is Varshith, and I play an important role here at EPAM. I work alongside some amazing set of individuals and have experience in the space of ML architecture, ML ops, LLM ops, and also data engineering. So I work across multiple domains and multiple industries, and I have insights on where teams and organizations usually struggle to gain their objectives in the AML landscape. So I would like to present some of my insights here and my learnings and experience in this industry. And I want to see if I can spark or evolve in thought for everyone attending this session. So let's get started. So as part of the first part of this session, we will look into the problems usually a lot of teams face as part of their AML journey. And we'll also see how does these problems create an impact as part of building AML solutions. So now let's look at the big AML challenge that a lot of teams face. So these are some four key recurring challenges that a lot of teams face as part of building AML solutions in general. So if we get started, like the first recurring theme of challenge that a lot of teams face is around creative barriers. So what happens is when multiple teams are working in a complex stakeholder scenario, there is always a chance that the effectiveness of bridging the requirements and the expectation of building a solution is not impactful enough, and the handoff between multiple stakeholders cause impact in the way the solution is being built. It could be something as simple as, let's say, business SME and data scientists are collaborating to understand the right fit for a specific business problem. Or it could be something as simple as, let's say, a data engineer trying to set up the features that are required for models in production, right? So this is a recurring theme of challenge that happens when you're building AML solutions. And the second theme of challenge that a lot of teams face is a lot of teams often end up investing a lot in terms of infrastructure and expertise. And this leads to something called high capex and resource constraints. And this in most of the scenarios, this happens due to a fear of missing out mindset without clear understanding on how should the ROI and requirement should look like from long-term perspective. And the third theme of challenges that a lot of teams face is from scalability and data point of view. Any team or organization that they start somewhere in this journey to reach to a scale where multiple teams could work and build solutions as quickly as possible. But what happens is whatever starts at a small scale doesn't work in the large scale in an enterprise or organization scenario. And they end up making some minor mistakes that could cause catastrophe at a large scale. And this causes issues in terms of how do you maintain ecosystem of data from long-term point of view. And finally, the fourth recurring challenge that a lot of organizations face is from governance and compliance point of view. What happens is as teams grow, organizations have to adhere to a couple of compliances, and they need to regulate how different assets they have has to be set up. So there is a need to maintain the governance over the assets that they have, and also there is a need to make sure that the data that they handle is compliant enough. It could be something like let's say they're trying to handle PII data safely, or trying to set up some kind of guardrails to your LLM solutions in a production scenario. So these are some key recurring challenges that a lot of organizations face. And now let's look at the statistics for context on how these challenges could create an impact in an organization or in a team that's working on AI/ML solutions. So the first statistic that we have is from TechSpot. So what this statistic says is 80% of AI projects fail, which is the double the failure rate of traditional IT projects, because they miss on setting up the fundamentals that are required while building AI/ML solutions. And the second statistic that you see is from Amazon on Business Insider, where they mentioned that every developer effectively spends 1 hour coding, and the rest is consumed by unproductive tasks like setting up documentations, debugging, setting up their development environments, etc. So they end up being productive only 1 hour a day, which accounts to approximately 13% of their time in a specific day. And the third statistic that we have is from IBM, which is around escalating compute costs. So what IBM has mentioned is between 2023 and 2025, in 2 years, the compute costs that are required to set up GenAI use cases have increased by 89%, which means your effective budgets that are there in each project are increasing to make sure you have the right solutions in place. And the fourth statistic that we have is around the training costs, the percentage of training costs that contribute in a specific project, which is approximately 80% of training costs. So what this statistic says is like the amount, the training cost that is incurred per training run is somewhere between 4 million to 200 million, which is a large part of the operational expenses or the capex that's involved as part of a GenAI or a ML project. So now, given the statistics in context and the recurring theme of challenges, let's deep dive into the life cycle and different phases of how an AI/ML solution is built. And let's look at what kind of challenges that could come up from a team's point of view and an organizational point of view. So let's dive into the life cycle of an AI/ML solution in general. So what happens when you're building an AI/ML solution is it starts with a business problem, and then you have three different phases, which are design, develop, and deploy, where different stakeholders across organizations come together with an objective to solve this business problem. So in design phase, you look at how your problem statement, the AI/ML solution is the right fit for your problem statement. You start exploring how should you address this problem statement from the lens of AI/ML solution, and then you try building a solution around it. So you try to create a blueprint on how should the solution look like so that the problem statement is addressed. Then you have the develop phase, where you use that blueprint to develop the solution that's needed as part of solving the business problem. And there are different set of stakeholders who are involved in this phase. And finally, you have a deploy phase where the developed solution is deployed and it is accessible to the intended business users to create an impact for the business problem that's there from the start. So what happens in all these three phases is there are different scale of teams who work on solving different use cases. And there is always a extremity kind of scenario that happens while building these solutions. So let's say you have a small team. What happens is given the current restrictions sometimes these teams have, they end up skipping some best practices while trying to navigate to this entire end-to-end phases of building the solution. Similarly, like when you have large scale teams, it's completely opposite of it. What happens is at an organizational point of view, you start setting up too many tools and processes, which create hurdles in terms of building a AML solution more effectively and solving the business problem we have at disposal, right? So in order to do that, let's also deep dive into see how does an ML lifecycle look like, and how is the AML lifecycle is evolving in general, and what are the challenges that a lot of teams face as part of these phases, right? So if you look at the traditional ML lifecycle, as I mentioned, it starts with a business problem, and you try to create a blueprint out of it on how do you solve it. And when you start developing your problem, the lifecycle starts with data collection, and then you have data pre-processing, where you pre-process your data to give it a standardized approach, and then you start training the model with different versions, and you start experimenting to evaluate how does the model look like in terms of solving the business problem. And finally, you deploy the model in a production scenario, and you make sure the model is available for the users that are intended. And then you set up some kind of a monitoring observability, given the models tend to drift off from the primary objective of why the model has been built due to many reasons. And you set up some kind of an observability ecosystem to see if the model is not performing as needed, and you start optimizing and retraining your model based on how the model is behaving. So it becomes a cyclic process, and you end up needing different types of resources in terms of building this entire cycle so that this model supports the business objectives, right? And what happens is in recent time, given the rise of Gen AI, this ML lifecycle started growing into a different complexity, and it started looking something similar to this lifecycle that you see on the screen. So it started. So the basic lifecycle that you had, it started evolving into multiple layers. Like let's say you had the concept of prompt engineering coming into the context. You had the concept of creating vector embeddings to maintain different types of data. It started evolving from a, let's say, structured to unstructured approach. And then you have different other complexities in this entire life cycle, like the model management, the ability to fine-tune models that you have at disposal and then deploy them, the ability to set up some kind of an inferencing setups, or ability to set up some kind of an automation workflows that's needed as part of this entire end-to-end life cycle. So the life cycle has evolved with some additional complexities, so that the process of building AML solution in the three phases has become a little bit more complex. So eventually, like tying all these things together, what happens is it gave a scope to too many challenges that could come up at an enterprise scale. So let's say if you look at data management, a lot of organizations have this dire need of maintaining data with right validations in place, having make sure your data has the right quality, you have the standardized data that's available, and then there's some kind of governance and lineage that's attached to it, right? And then there came a need to make sure you have automated pipelines, like you have multiple workflow orchestrations, you have predefined CI/CD that helps you to deploy models more effectively or impactfully. There was a need to set up retraining pipelines which could be automated, and the deployment pipelines or the monitoring pipelines that needed as part of the entire process of building the cyclic life cycle, right? And then there also came a need of making sure you have the right infrastructure, the compute that's needed, that's attached to it, and the storage that's needed, or the network that's needed as part of setting up this entire end-to-end life cycle. So the complexity of problems started increasing, and there also came a need where the entire life cycle or the tools that you're using, the solution that you're using, has to also connect with the existing enterprise solutions or the existing internal enterprise systems that we have in place, so that these systems talk to each other and make sure it creates an impact in terms of building the solution to a business problem. So this is how like a lot of challenges come up when you're trying to set up a scalable AML solution in an enterprise scenario, and the journey to create AI solutions rapidly becomes even more difficult as and when the projects grow and multiple use cases start coming into the context. So now, given you have seen different challenges that you have, and you have seen different how the challenges evolved based on how the life cycle is present, how the ML life cycle is present. Now let's look at how, what are the existing solutions that are in place, and how are the solution helping us. So primarily, if you have to look at the solutions that are present, there are three category of solutions that you have in terms of building an AI ecosystem or a scalable AI using MLOps and ML engineering. So if you look at those three categories, the first category of solutions is open source tools, and then you have licensed solutions, and then you have vendor lock tools that are provided by different cloud providers. So all these three category of solutions have their own gaps, and they also have their own pros that could help you build solutions more rapidly and easily. So if you look at open source tools, there are tools like MLflow, Kubeflow that are primarily targeted to specific components of your ML lifecycle, and they work effectively at a cost, and they help you solve the problems that we needed at that specific lifecycle. But the challenges that come up is like you need a lot of in-house expertise to make sure the tools are set up correctly and you maintain the tools as needed so that you can build AI solutions based on the business problems that come up, right? So it's always best if you have some kind of small to medium-sized teams with technical expertise who can set up this tool as an ecosystem, and they can help you take the process of building AI solutions at scale more easily and fastly. Then you have the second category of solutions, which is licensed solutions. So these are like vanilla type out of the box offerings from different platforms like Databricks or Data IQ. So they have very comprehensive set of features, and they have very good enterprise level support that's offered. But the challenges that you see from a project point of view comes from the budgets, where the licensing is potentially expensive, and sometimes there is some amount of learning curve involved. But it's always best that we use these kind of solutions when you're trying to look for a ready to use out of the box platform that can help you build AI solutions rapidly. And finally, we have a third category of solutions that that help you solve these challenges at one place, which is vendor lock tools. So you have tools like AWS SageMaker or Azure ML that are offered by different cloud providers as part of their ecosystem. And these tools are very good at interacting with their own cloud services or interacting with the cloud resources that are available in their ecosystem. And this is best for teams that are already invested or involved in that specific cloud ecosystems, and they are fine being a vendor locked user and building solutions, AI solutions at scale. So these are three different category of tools that help you solve different challenges that come up at an enterprise scale. Now let's double click on these two categories of tools and see what are the exact platforms that are there, and what kind of pros and cons these platforms offer. So if we double click on these two categories, these are some primary large scale platforms or tools that are offered to solve different challenges that come up when you're trying to build scalable AI. The first one starts with Databricks, then you have Data IQ, SageMaker, Azure ML, and then you have Google Vertex AI. So each platform has their own strengths, and they also have their own key gaps or weaknesses. But primarily, let's say if you're an organization, if you're a team looking to use out of the box solutions, and you have large scale data processing that's needed, a platform like Databricks works best because they have very good integration with some open source tools, and they also have very good capabilities to process big data. Similarly, let's say if your team has less technical expertise and they're more comfortable with building solutions using no code or low code environment, a platform like Data IQ works best in terms of building the solutions, because these are more graphic UI in nature, and you can build multiple ML or AI solutions in place by using an approach like Lego bricks, the way Lego bricks works, right? And then you have tools like SageMaker, Azure ML, and Google Vertex. These are very similar tools, and they have very strong integration with their own cloud ecosystem, and they have very good integration with the resources they offer in terms of how you set up governance, in terms of how you set up access to the platform or the cloud ecosystem in general. But what happens is in all these tools, there are some key gaps that could break or it could hinder you in terms of building the solutions from the long-term perspective. So now let's look at how these key gaps could impact the way you build your solutions in general from building from ML lifecycle or building AI solutions in general. So these are some key gaps that are present in most of these platforms. So let's say if you want to build your solutions in a cross-platform or a hybrid scenario, there is always a limited support in all of most of these platforms that are offered. Similarly, let's say you want to set up some kind of an end-to-end lineage tracking or observability, there is always some kind of limitation that comes up because you don't have that flexibility to use different types of tools and set up different types of features that are needed from a team objective perspective or from a platform from an organizational objective perspective. Then later you have challenges with, let's say, if you want to do large scale deployments, or if you are looking to go as serverless as possible from architecture point of view. And you also have challenges in terms of setting up the right development environments because in most of these platforms, the development environment is restricted when you compare it to something like a VS Code. You don't have any user profile customized environments that could help different stakeholders that are involved to productively work on the things that are needed. Let's say if I'm a data scientist, I might need a different set of tools compared to a data engineer, or let's say an ML engineer who's working on solving problems from a different lens, but for the same use case, right? So in most of these platforms, you don't have that ability to customize your development environments and embed best practices from an organizational point of view. And then you have key gaps like let's say you have multiple enterprise internal systems. It's very difficult to integrate those tools together and then set up an ecosystem. Or sometimes, let's say, even if you have the possibility as well, there's always a complex learning curve that comes with it in terms of how do you set up this end-to-end integration. So these are some of the key gaps that you see in most of these platforms. And having said that, these platforms solve the challenges that enterprises face from a specific lens that could help them build solutions more impactfully or effectively. So looking at the existing solutions that you have, how do you it's important how do you perceive on building an AI journey in an organization point of view so that it could help teams working on building AI solutions more effectively or more easily. So I will now present a structured approach that I put forward from my insights that I have while working in this domain. And I'll put a perspective on why it's important to have these kind of solutions so that they help build an ecosystem of AI tools easily. So the approach to solve the challenges that I have explained earlier is to make sure that you have an ecosystem of open source tools, and these tools work together tightly, and they help you build AI solutions more rapidly and fastly. So how should the approach be when you're trying to create an ecosystem? It's important that you create a unified tools and marketplace for assets. So let's say if you want to set up some kind of model registry, you can use open source tools like MLflow that can help you set up the process of bookkeeping or model registry that's needed as part of experimentation. Or let's say if you want to set up some kind of observability, you can use tools like Grafana, which support open telemetry, and then you can set up end-to-end monitoring from an organizational point of view. So it's important that you handpick the tools that are required as part of the ML lifecycle that's involved, and then you set up a tight integration or ecosystem that helps you to use these tools effectively, and the stakeholders involved can leverage these tools more effectively to build the solutions end to end. So some of the objectives while when you're trying to set up some kind of an ecosystem to solve these challenges is have a unified tools and marketplace for assets, and try to automate any pipelines or any processes that is involved as much as possible, and try to set up a very robust scalable deployment workflow that can help you make sure the process of the life cycle of bringing a concept of AI solution into production as quickly as possible. So having when you try to address these challenges from an organizational point of view, and you try to keep in these priorities of building an ecosystem in check, you end up having multiple benefits in a two-tier mode. The first tier is you have benefits at an enterprise level, and the second tier of benefits that you will face is from a use case or a project point of view. Now let's look at how does building an ecosystem with this approach could give you benefits in terms of building AI solutions more rapidly and reducing the challenges that are involved when building it. So first, if you look at different enterprise benefits that could come up as part of this proposed solution is one, you will have access to fast time your market as fast as possible because you have an ecosystem of tools, ecosystem of assets that can be repurposed together and and the AI solution can be built as fast as possible. Second type of benefit that you could encounter is the cost efficiency that comes with it. So given you use open source tools and you set up an ecosystem, your capex is as less as possible. And you also, when your approach is trying to create an architecture, something like an serverless architecture, your cost starts reducing rapidly, and you try to prioritize the cost where the cost has to be allocated as part of building your AI solutions. And the third type of benefit that you get is the collaboration that gets improved because these tools help you to work tightly from different stakeholders' point of view, and they help you to solve the business problem as easily as possible without derailing ourselves with challenges that could come up with that we come up with at an enterprise scale or an organization scenario. And finally, given you set up your own ecosystem, you will have control to set up the kind of compliances that could be in place at an enterprise level, the kind of governance that is needed to manage accesses, manage data, manage assets that you own, so that the solutions are built at cost and scale easily. Now let's look at the benefits that lot of lot of projects that are working on building AI solutions would face. So if I look at classical ML development point of view, you could see benefits like having a ecosystem of data and model artifacts so that you can come up with something like you have a marketplace of data and model artifacts with right accesses in place, and multiple projects can leverage this data and build solutions as quickly as possible. Remember, because every ML or AI project requires data, and the data is the process of procuring data is not as easy as possible. It would create an impact or derail you in terms of building a solution effectively or productively. Then you'll have access to building custom ready to use workflows that could automate the way you retrain your models, the way you deploy your models, the way you monitor and observe how your models are behaving in production, right? And then you have this benefit of making sure you have very robust, secure way to procure the data, train the data, create your models out of it, and then deploy it easily. So these are some of the benefits that classical ML workflows would enjoy as part of having an ecosystem of open source tools. Then finally, if you look at how does the evolving LLM landscape look like when you have an ecosystem of tools, so there are some additional benefits that come up from when you're working on LLM use cases as well. Let's say if you want to host LLMs and infer them, you could have that automated pipelines to fine tune them as needed and then deploy them easily. Or you could have the benefit like having a templatized RAG workflow that can be just that can be repurposed for different use cases and then deployed. So because you have a unified ecosystem, the effort that's needed to build your solutions become more easy, and you also have that ability to scale up and scale down as needed based on the project use cases that based on the project use case and the compliance and the priorities that are involved in that specific project. So in total, when you try to build an ecosystem, you will have very key benefits that could complement the gaps that you could see in the existing platforms that are there in market. And you can leverage this and bring an ROI to your project or your initiatives that you have from long-term point of view. So let's say if you create this ecosystem, you'll have that ability to set up an SSO-based RBAC for a very secure way to access your assets and build your tools. You'll have that ability to set up a serverless and scalable infrastructure, and you'll also have that ability to set up end-to-end governance over your assets that you have. And then you'll also have benefits like you'll be able to optimize your costs, and you'll be able to use the best architectural practices that are there for organizations or enterprises in place. And then you'll also have access to, let's say, improving the collaboration, improving the way the tools are available for different stakeholders, so that the process of building your AI solutions is easy and it doesn't derail you from a lot of challenges that will come up when you're trying to scale up and at an enterprise scale. Now let's look at some of the impact that MLOps and ML engineering has done when done correctly for different organizations. So these are some of the metrics that I have pulled in from public domain. If you look at it, there is some organizations have reduced their deployment time. They have improved their model runtime. From, let's say, a CPG company has improved their training time from 8 days to 14 hours, which is a huge improvement in terms of how the resources are effectively used and how the budgets can be repurposed for different use cases or business problems that could be solved, right? Similarly, you also have impact in terms of cost optimization and scalability, where a hospitality firm has achieved 40% reduction in annual cost by just making sure their ML lifecycle with MLOps is streamlined correctly and right tools and ecosystem is in place. And similarly, there is also increased operational efficiency in some of the companies that improve the productivity of stakeholders that are involved, that improve the time to market or the speed at which the solutions are built reliably without any risk. And then there is also impact in the success rate of projects. As I said, like most of the projects fail because the fundamentals of building the AI solutions are not in place from an organizational point of view. And most of the organizations that have implemented the process, that have understood the processes that are required, and then implemented the right ecosystem of tools that are in place, the success of building the projects have the building solutions as a project has improved significantly. And one of the stats is 90% of organizations have implemented MLOps, and they have seen significant improvements in the operations that they have. So, in summary, it's always important for us to understand what are the challenges that could come up. How do we solve these challenges by understanding the type of use cases you have from a long-term point of view, and how do I create an ecosystem of tools that could talk to each other and improve the process of building AI solutions at scale. So these are some of the useful links that I've added. So here you can have access to different statistics that I've mentioned in this presentation, and different type of impact that MLOps and ML engineering has contributed to at scale. And you also have links to different partners. If you're interested in this topic of MLOps and ML engineering, you can visit any of these links to understand how do you improve the process of building AI solutions that are at scale and that are very reliable. So I'll open the floor for Q&A, and Lisa, I think it could
Yeah.
could help. Over to you.
Thank you, Sai. Yes, we have questions for you. So the first question is, what are the key differences between MLOps and traditional DevOps?
Got it. Yeah. So there is a difference in building the way your automation of MLOps and DevOps cycles are involved. So DevOps primarily focus on how do you package your software applications and then deploy them in a production scale. But when it comes to the scenario of MLOps and ML engineering, it's important that you understand the life cycle of the traditional ML life cycle or generative AI life cycle, and then you implement the right set of automation that's involved. There could be something like, let's say, collecting the right metrics that are needed to deploy a model, or setting up the, let's say, strategies on how do you handle if your models are degrading in production. So there is an increase in complexity or steps that are needed because there is an additional ML life cycle that's involved while building the MLOps, building an ML or AI solution. Hope
Got
that
it.
answers the question. Yeah.
Thank you.
Yeah.
Second question. Probably not all problems can be solved with ML. How to understand that?
Yeah, this is a very good question because a lot of projects fail because all problems are looked from an AI/ML lens. What happens is this has to be something that should be tackled in the early stages of developing a project. Remember, as I mentioned, like we have three key phases of developing an ML solution. You have the design, develop, and deployment phase. So it's important that we tackle in the design phase. Whenever you have a business problem, you need to strongly collaborate with someone like a data scientist who can understand if this problem can solve from ML lens or an AI lens. Because some solutions are always cheaper than ML and they're more effective enough in most of the cases. It's important that you rule out the problems that cannot be addressed, and then you focus on the ones that could actually solve you from that could actually solve your business problems from an ML point of view.
Okay, that makes sense. In your opinion, what is the most important step in GenAI lifecycle?
Yeah. So it depends on the organizational priorities and the use case that you're working on. There are multiple use cases that are involved in a GenAI scenario. You could have something like a chatbot. You could have something like a RAG application that's set up, etc. Right? But something that's very important that I see, irrespective of use case, is the last part of deploying a GenAI solution, where it is more focused towards the compliance and the governance that's involved. Let's say you're setting up the right guideline guardrails that are required when you're using a GenAI solution, so that it doesn't generate output that's not intended to be, or setting up the security layer so that there is no prompt injection attacks that could happen or something like that. This is a very important part, the important step that is there irrespective of use cases that you work on, and it should be part of any GenAI lifecycle that you're trying to build.
Hmm. Okay. About monitoring, how you monitor and evaluate data drift? What tool you can use for that? Same question about feature store. Did you use it? Is it worth to use?
Okay. So I'll answer the first question about monitoring on how do you monitor different models. That's the right question, I guess.
Uh, how you monitor and evaluate
Mhm.
data drift? What tool you use for that?
Yeah. So data drift is monitored using different KPI metrics that you have for your data. There are a lot of open source tools that are available. If I recollect correctly, there is a tool called Great Expectations that is more on data quality, and there is another tool. I'm just trying to recollect, but I can share the tool name. So these tools have out of the box KPIs that can help you monitor data drifts for different type of data. Having said that, there is always a priority to understand how does the data drift happen based on the structure of your data, and there's a need to create KPIs on what KPIs works best for different types of data that you handle in your day-to-day activities.
Okay. And the same question about feature store. Did you use it? Is it worth to use?
Yeah. So feature store is something that is worth to use when you're trying to implement at an organizational scale, because feature store is something that gives you the ability to have metadata attached to different features that are available. And it is worth to use when you have multiple teams that are involved and they're trying to derive features from the same set of data. Let's say if you have one or two teams that are working on singular or multiple one or two use cases, it's generally not worth it. But if you're trying to look at scaling up your teams and use cases in a long term perspective, it's best that you start implementing feature store in a small scale scenario, and then you start scaling up feature store when you start adding more use cases and projects around it.
Thank you, Sai. Yeah. The next question is, which MLOps platforms offer the most unified ecosystems today?
Yeah. So in today's scenario, the best platform in my perspective that offers unified ecosystem is Databricks. But having said that, like it has its own weaknesses. Like let's say it has complex pricing, and then as I said, most of the platforms doesn't offer the flexibility of having customized development environments for each stakeholder. But having said that, the other parts of lifecycle, the way it has been approached, Databricks I feel has the best approach in terms of solving most of these challenges. But again, it doesn't solve 100%. You need to add some more layers from your end by prioritizing what's best for your organization or team.
Okay, thank you. How can smaller teams or startups implement MLOps principles without large infrastructure?
Yeah. So it's always an advantageous when when smaller teams are trying to get into this process of MLOps and ML engineering, because it's a clean slate. And if you're trying to create an MLOps ecosystem with very small infrastructure, it's best that you try to leverage the open source tools that are available. There are very good open source tools that solve specific niche of each ML lifecycle. And only thing is you need to bring on technical expertise so that you can bring these tools together and they talk to each other in terms of building the solutions. And if and these tools help you reduce costs and also maintain infra as per your needs that are there in terms of building these solutions.
Mhm. Okay. Is it possible to say that MLOps approach helps to reduce team size and solve a problem with less engineers?
Uh, it would reduce the inefficiencies that are involved, and it could potentially reduce your team size, but it again depends on how you have structured your teams and projects. So in most of the cases, MLOps gives you that flexibility to automate and apply best engineering principles in terms of developing AI solutions. And that helps you to remove the unproductive work that's involved. And if that leads to reducing team size, yeah, it does reduces team size. But in most of these scenarios, the challenges come because the automation or the principles are not correctly in place, and it is leading to unpredictable work. So it's more about it improves the productivity of each stakeholder that's involved.
Okay,
Yeah.
thank you. The next question, does it make sense to set up a MLOps process if we need to create a POC with ML AI as faster as possible?
If it's a singular project that you're working on, it might not make sense from the budgetary or investment point of view. But if you have multiple POCs or multiple use cases that are involved, then it's best that you try setting up MLOps process. Having said that, let's say if you're starting today with a small POC and from long-term perspective, you see that you have multiple use cases coming in, it's best you start enforcing the processes and tools that are required in today's world so that these tools will reap your benefits in the longer run.
Mhm. Okay. The next question, how you fine-tune LLM models? Laura, Clara, can you give us more details about fine-tune LLM models? Tools, constraints, data sets?
Yeah, so there are some specific tools that are used in different projects. I think LoRa is a very common one that's used, but we use these tools in terms of running fine-tuning models using the base data set that we have. I can share the tools. I don't have the list of tools handy with me, but I can share the tools with you offline if needed. But there are specific set of open source tools that help you to fine-tune models that are there that are available, let's say in Hugging Face or something like that.
Okay, thank you. And it was the last question. So thank you, Sai, for this presentation,
Thank
and
you.
thank you everyone for joining today's discussion. In the description, you will find the link to access the presentation file and the recordings. And don't forget to say speaker thank you by awarding a badge and rating the talk. Be sure to subscribe to our channels for more content like this, and we hope to see you at the next session of the Winter Data Meetup. Have a good day. Bye bye.
Thank you everyone for joining.